Well, greetings, everybody. Let's look at this question that is from MyMathLab regarding how to make a frequency distribution. Okay. Now, when we have a frequency distribution, we have to start with data. We have to start with numbers or measurements or something like that of some kind. And I don't see that anywhere here. I just see the prompt for the question, but I notice here it says click the icon to view the data set. That's what we really need to look at. Okay, so I click this and it opens it and it says apparently we have some medical study and we're measuring triglyceride levels of 26 patients, and here they are. Okay, each number represents the measurement for one of the patients in this study. So that's what this table, this frequency distribution, is based on. It's based on how I can organize these numbers. Okay, and I say organize because one aspect of statistics is taking data which is all mixed up like this. All these numbers are just random, they're just there, they're not organized in any way, there's no meaning to it, and my job would be to organize it and present it in some way that somebody could look at it and understand it a little bit better. Okay, but before I go into that, let me give you some notes on what we would need at the bare minimum to make a frequency distribution. We need two things to start with: the range and the class width. Okay, the range is the largest datum minus the smallest datum. What I mean by that is the range is the largest number in the data set minus the smallest number in the data set. So let's open this data set again and look at it. So can you look at this and try to pick out which number is the biggest and which number is the smallest? I mean, if you had to, you probably could. But I think if you're going to look through unorganized data and just pick out the numbers, specifically whichever numbers you wanted, whether it's the biggest or the smallest or the one right in the middle, who knows, you're more likely to make a mistake if the numbers are just all jumbled together and unorganized. So I noticed I could do one more thing with this data set. If I click this icon, it says open in StatCrunch. Now StatCrunch, that'll be a real important tool for us to make a lot of what we do much easier throughout the semester. So I'm going to definitely take this data set and open it in StatCrunch. When I do that, I get basically a spreadsheet, and here we are looking at it. All right, and it's still unorganized. The numbers are still random. I see they jump around from bigger to smaller and so on. It would still be hard to look through this list and pick out the biggest number and the smallest number. I'm not saying you can't do it, it's just you're more likely to make a mistake. All right, so I notice one more thing I can do. I can click this down arrow and I can sort it. Okay, I'll sort it ascending, meaning from least to greatest. All right, so now it's sorted and I can't miss it. The smallest number is 138 right there, and the biggest one is 461. Okay, hard to make a mistake finding the largest and smallest data. If it's sorted from least to greatest, I recommend that you do that. Use StatCrunch to your advantage in this way. So, all right, now I'm going to go back to my notes now, and it says, okay, range largest datum minus smallest datum, 461 minus 138. So the range is 323. Now we get that number to find the class width. Okay, the class width is used to find these class limits. See how it says class right here, and then there's a small number to a big number, and then the next class is another small number to another big number. Those classes are made of these class limits from start to finish. Then the next class, start to finish. I use the class width to figure that out. Okay, so here's how we do that. I take the range, which I've already found, and I divide by the number of classes. Every frequency distribution will have a certain specific number of classes. I can look at this one and see 1, 2, 3, 4, 5 classes. The answer template has 5 classes. Or I can even look in the instructions and it says to make a frequency distribution using 5 classes. So it's like either way I look at it, there's 5 classes. Okay. So, all right, I got range 323 over number classes 5. That's 64.6. Now, when we do that, when we find the class width according to this formula, we always round this number up. Like no matter what. Like if this was 64.1, I would still round it to 65. That's just the nature of the procedure. Always round it up. Okay, no matter what. 64.1, that would be 65. 64.2, that would be 65. No matter what, 64.6, that would be 65. So we'll always round that up. Now, that number is what this table is largely based on. It's what the frequency distribution, which I'm going to piece together, is largely based on. So let me show you that. Over here, I have the completed frequency distribution. And I thought I would just show you how, retrospectively, looking back at it from being finished, how I put it together. So the lower class limit of the first class, meaning this first number here, or if you're looking on MyMathLab, that first number right there is going to be the smallest datum in the data set. Okay, that's where it's going to begin. So I could, if I wanted to, look back at the sorted data, see that's 138's the smallest. So, it's always going to be like that. I'm going to start at 138. It's just the way that it is. Okay. Now, as far as finding the rest of it, okay, here's how that works. There are various closely related, similar ways you could put this together, but I have to decide more or less one way to show you, so here's how I'm going to do it. I can, from this number now, let's say that I start with 138, pretend I don't know the rest of this. How I find this number is I add the class width. Okay. And then I go through again and I add the class width. Class width is 65. So whatever the class width is, I start with the smallest number in the data set, and then I get that next one by adding the class width 65. I add again, and I just keep going. And that's going to allow me to find the lower class limit of each class. Okay. All right. So like if I did that, then at this point, here's what I would be looking at. I'd say, okay, I'm like kind of pretending I don't know these other numbers yet, even though it's complete. This one would be 203. Okay. And then I add 65 again. That's 268. And then I add 65 again. That's 333. And so on. Okay. Last one, 398. So doing it like that, as I'm outlining this procedure for you, this is where we would have it. I put that smallest data in the data set first, and I added the class width to get the lower class limit of each class. Okay. All right. Now what about the rest of them? How do I know that this first class goes from 138 to 202? Well, that's pretty easy. It works like this. This one's got to end where that one picks up from. So like if this one picks up at 203, this one ends at 202. It's just going to be one smaller. Okay. And this one's got to end where this one picks up at. So it's just one less each time. So if that one picks up at 268, well, that means this one ends at 267. Okay. And so on and so forth. If this one picks up at 333, this one ends at 332. So you get the idea. Okay. This one picks up at 398. That means the one before it ends at 397. Okay. And so on. Now, what about that? That does leave us with this one, though, because you see how I would say this one ends where the next one picks up from. Well, there isn't a next one. Like that's the last one. So what do you do there? Well, okay. So for this last one, what we add to get there is one less than the class width. This is the class width. So I add one less than that. So what's one less than 65 is 64. All right, so that's how you go all the way through and construct the classes. Take the smallest datum to start with, add the class width to get the lower class limit of each class. This one will end where that one picks up, and so on. And to get that last upper class limit, add one less than the class width. Okay, so there's that. Now, so far then, here's what that leaves us with. It leaves us with this. Okay. All right. What about the frequencies? What do we mean by those? Well, the frequency, this column right here, is just in this data set, in this study, of all these patients and their triglycerides, how many have triglycerides between 138 and 202? Okay. That's what frequency means. It's like I just want to kind of organizing them, and I would say, here's how many patients are in this range. Here's how many are in this range. And when I do that, like I see that, well, most of them are on the lower end. Where if I take that original data set the way it was given, it's just all unorganized. It's hard to draw conclusions. It's, difficult to look at that and just instantly know that, well, most of the patients are on the lower end. If I organize it in this table, it's easier to see that. So now I need to go through and count how many patients are in each class. How many patients have triglycerides from 138 to 202. So I can do that again in StatCrunch. I think, like I said, it would be hard if I was just looking at the data and trying to count that up. That would be difficult. So here I've got it sorted. So what was that first class? 138 to 202. So that would be up to here. These are all the patients that are within 138 to 202. And I can count them up, and there's 14 of them. So because this is sorted, it makes it easy to do that. All right. Okay, so let's see. I put then, as you can tell, 14, because I counted 14 in this range. And then I can just go through and highlight the rest, like how many from 203 to 267. Well, 203 to 267 would be these. Okay, these are the only ones that have that triglyceride measurement to be between 203 and 267, and that's 4. Okay, now as you can see from there, I can go and just count. Since this is sorted, I can count how many are in each class. Okay, all right, so that's how I get this frequency number. Okay, so that if I was doing this on my math, I'd put 14. Okay, counted that up, 4, 4, 1, and 3. Okay, this last number right here, now whenever we see this symbol in our class, it's going to mean sum or add everything together. And if I add everything together, what do you think I'm going to get without actually doing it? Like, what would make sense to get? So these were the tallies of how many patients had triglyceride measurements within each range. How many patients were there? There were 26 patients. So if I add those together, it makes sense I get 26. But sure enough, 14, 4, 4, 1, 3, that is 26. Okay. Okay, so that's what that number means, if it seems a little weird. Last thing is the relative frequency. Relative frequency means it's like saying how many out of the total. Okay, so there might be 14 patients in this study that have triglyceride measurements between 138 and 202. But like 14 out of what? Like whether like 1,000 patients, because that's not very many. 14 out of 1,000, there weren't very many in this range. So to find the relative frequency, you just do the frequency out of the total. So if there are 14 patients that had triglycerides like this, the relative is 14 out of 26. There were 26 total. All right, now when you do that, you can divide each of these numbers and you get a decimal. But just be careful with that. It does say, like for just about every question we see on MyMathLab, round your number to so many decimal places. Okay, so if I look at these instructions down here, as far as rounding goes, I see round to the nearest thousandth. So that would mean 3 decimal places. 3 decimal places, nearest thousandth. So when I take 14 over 26, I get 0.538. I got a lot more numbers than that on my calculator. It says 0.538, and there were like numbers all down the screen. But I'm rounding to the nearest thousandth, so it's 0.538. So when I go over here, I'm going to put 0.538. Okay, 3 decimal places. If you don't follow the instructions on rounding, okay, then, whoops, it will count it wrong, unfortunately. It's like MyMathLab sees things black and white, right and wrong only. And even though if you had the right number and you divided it correctly, but you added another digit there, or you didn't round it to 3 places, it will count it wrong. So just pay attention to the rounding instructions. Okay, so that's how you can make a basic frequency distribution with even the relative frequencies included. If I can leave you with something that will be, lasting throughout the semester, always open the data sets, and it will almost always be to your advantage to open it in StatCrunch in addition to that.